Your first job today is to show your partner how to calculate the molar mass of CO2. So if you need some paper, grab some paper, okay? There is blank paper at the back if you want to grab some, if you don't have anything to write on. You will probably want your periodic table. Let me know if you need to borrow one. It's really hard to do without your periodic table. You need to have a periodic table. Unless you've memorized some of the information. So on your periodic table, what is that number there? It is the atomic mass. And what's the unit of atomic mass? AMU. But it is also, what other kind of mass? The molar mass. And the unit of molar mass, it's not just grams, it is grams per mole, okay? So if you want to calculate the molar mass of CO2, you need to know how many carbons are in it and how many oxygens are in it. How many carbons are in CO2? There's one carbon, so we're going to have 1 times 12.0, And I'm going to write out absolutely everything. After this unit, when you do molar mass, you can just do it on your calculator, but for this unit, I would like you to actually write out your work. So we have 12.0. How many oxygens do we have? We have 2 oxygens. So we're going to take 2 times the molar mass of oxygen, which is 16.0. And now once we have those, we're going to add them together and we get 44.0. And our unit for that is the gram per mole. You now have one unit on top of another unit. What do you think that's good for? One unit on top of another unit. It's a wonderful unit conversion. It's a wonderful conversion factor, okay? Molar mass is a great conversion factor. Tell your partner what units we are converting if we're using molar mass. So what units will we be converting between if we're using molar mass? Moles and grams. So you know how earlier this week I was asking you for 2 conversion factors related to the mole? Now you know 3 conversion factors related to the mole. So let's summarize 3 conversion factors related to the mole. In fact, actually, we know 4 conversion factors related to the mole. I'm sorry, because we learned one last day. 4 conversion factors related to the mole. Let's see how many we can get. See if you can tell your partner at least 2 or 3. See if you can get to 4. Okay, what's one of them? Any one of them? Yes. Avogadro's number. And what is Avogadro's number useful for converting between. It's useful for converting between something and something else. No, we don't know? Moles, yes. So this is good for converting moles of A into, So if I were to write Avogadro's number, what is Avogadro's number? 6.02 times 10 to the 23. What unit goes with that? Particles. And I'm going to call them particles of A. And you can convert between moles of A and particles of A. What is conversion factor number 2? Yes. Mole ratio. Yes. Tell your partner, what are we converting when we're converting the mole ratio? Actually, I should have written it a little further down because I'm running into the other one. What are we converting when we're using the mole ratio? We're converting not actually particles in this case. Moles. And we're converting from moles of A to what? Moles of B. And where do we get this ratio from? No, we don't know. Yes, it comes from the chemical formula. So for example, CO2, we might have 1 mole of C for 2 moles of O. Or we might have 1 mole of C for every 1 mole of CO2. Any sort of thing you can get from that compound. I'm not going to write the third one. There's a third one you can get out of it, moles of O2 to moles of CO2, but I don't think we need to write them all. So we have Avogadro's number, we have the mole ratio, we have the particle ratio. Yes. And what is the particle ratio good for converting? Particles. Particles of A, 2 particles of B. Oh, that wasn't good. Highlight. There we go. That's better. Particles of A, 2 particles of B. So for example, we'll use CO2 again. We could have 1 C atom for every, anyone want to give me something to go on the bottom of that? 2 O atoms. Anyone want to give me another one? 1 C atom per 1 CO2 molecule. Yeah? Do we want a third one? Yeah, let's do the third one. 2 O atoms per 1 CO2 molecule. And we could do the same up here, is we could have 1 mole of O atoms per 1 mole of CO2. No, what? Yes, 2 moles of O atoms. Sorry. There we go. 2 moles of O atoms per 1 mole of CO2. There we go. So we have Avogadro's number. We have mole ratio. We have particle ratio. What's the fourth one? We just learned it. Molar mass. And it is for converting moles of A to grams of A. You have to stick with the same species, obviously, the whole time. And how do we find the molar mass? Yeah, we add up the molar masses from the periodic table. Okay, so let us do an example of using molar mass as a conversion factor. Ooh, I'm going to give you guys a tricky one to figure out the molar mass for, because that way we'll have practice doing it. Let's see, calcium phosphate. Dihydrate are contained in 25.0 grams of that compound. Before you do anything else, what would you need to figure out? Calcium phosphate dihydrate. So everyone try to write the formula for calcium phosphate dihydrate. Is good. Ca3PO42. And then I need to add on the hydrate. What do I add on? 2H, small 2, big O. Okay, so there is our formula. Now, this is kind of nasty, okay, in terms of just sorting out all the things. So for this one, I'm going to write out that how many calcium do I have? I have 3 calcium. How many phosphorus do I have? I have 2 times 1 is 2 phosphorus. I have 2 times 4 is 8 oxygen. Now, I'm going to show you a little cheat here for water, okay? Could you please just see if you can figure out what the molar mass is for water? You can even do it in your head if you want to. Yes. Now, if you can just pop out 18, that's fantastic. If not, you can say I have 2 hydrogen and I have 1 oxygen. And hydrogen is going to be 2 times, what's the molar mass of hydrogen? 1 point, not just 1, but 1.0. Your point zeros are important. If you do not write your point zeros, you will not get full credit, okay, because you'll be dropping sig figs. Oxygen, we have 1 times, what's the molar mass of oxygen? 16, just 16.0. So then we have 2.0, and 16.0, and we get a total of 18.0. What is our unit for that molar mass of water? Grams per mole. Now, it's really handy just to know the molar mass of water so that when you have a hydrate, you can just, instead of putting down, now I have 4 hydrogens and I have 2 oxygens, you could just write down instead that you have 2 waters. Yes? So that's optional, it's up to you. If you like to do that, if you don't like to do that, you could put it down as, how many hydrogens would we have in that 2 water? 4 hydrogens, and how many oxygens? 2 oxygens. So it's up to you. You can do them separately. You could put the oxygens together with your other 8 and have 10 oxygens. Okay, it's totally up to you which method you use. I like knowing that water is 18. It's just handy because then I can say calcium. What is the molar mass of calcium? Is it 40.1? Yes, cool. 40.1. Phosphorus, I have 2 of them. Molar mass of phosphorus is 31.0. I'm going to highlight my 0.0 so you don't forget it. Oxygen, we have 8 of them. Each of them has a molar mass of 16.0. Okay, and now we've actually figured out the molar mass of water, so we can say I have 2 water, each of which has a molar mass of 18.0. And now I do all my multiplication. Like I said, when you're in this unit, you probably want to show your work just so you don't get mixed up. Oh, 3 times 40.1 equals 120.3. 2 times 31 is 62.0. 8 times 16 is 128.0. And 2 times 18 is 36.0. Now I'm going to add them all up. 120.3 plus 62 plus 128 plus 36 equals 346.3 grams per mole. Very good. Grams per mole. So that's probably as gross as it's going to get for having to find a molar mass with a hydrate, right? And a bracket and all of that stuff. So don't forget, when you're counting up, you have to multiply what's on the outside of the brackets with what's on the inside the brackets. Okay. Just another note, using the periodic table that we are using, your molar mass will always have 1 decimal place. Yes? Because even though we're multiplying, right, and you're like, oh, I have 3 times 40.1, shouldn't that give me 3 sig figs? Not really, because what you're really doing is you're adding 40.1 plus 40.1 plus 40.1, which means you're going to that 0.1 position. Okay, so this multiplication is really adding. So you can be like, all of my molar masses have 1 decimal place, therefore I'm going to go to 1 decimal place. Okay, so it's kind of nice. You'll always know your molar mass will always go to how many decimal places? 1. Okay. If you use a different periodic table, something that has 2 decimal places, then your molar mass would go to 2 decimal places, but not with the one we have. Now let's go back to our question. What did our question actually ask us? How many moles, so I'm going to rewrite that down here. My unknown is how many moles Ca3 PO4 2 are contained in 25 grams. So my initial quantity is 25.0 grams of Ca3 PO4 2. Am I able to convert moles of calcium phosphate into grams of calcium phosphate? Do we have a conversion factor between moles and grams? Yes, molar mass. The conversion factor is the molar mass, which is in, of course, grams per mole. So our unknown is equal to our initial quantity times our conversion factor. So how many moles of Ca3 PO4 brackets 2 can we get if we have 25.0 grams of Ca3 PO4 2? What unit do we want to go on the bottom? Grams. Okay, so we need to put the grams of Ca3 PO4 2, oops, dot 2H2O, dot 2H dot 2H2O. I forgot that in all my places, 2H2O, dot 2H2O. Really regretting the choice of such a large compound, but at least now you know it will never be any worse than that, dot 2H2O. And then on the top, I want to have moles of Ca3 PO4 2 dot 2H2O. Whew. Most of the time they'll be much tidier than this, okay? And we have a molar mass, we just found it. It was 346.3. Where does the 346.3 go? On the bottom with the gram, 346.3 grams per how many moles? 1 mole. There's just 1 mole. Up here doing the dance, right? Okay, 1 mole per that many grams. All right, we're gonna get a fraction here, aren't we? 1 over x times 25 equals 0.07219. How many sig figs should we have? We have 3 sig figs here, 4 sig figs here, so that would give us 3 sig figs in our answer, so we need to round that then to 0.0722 grams. So you can take molar mass just like any other conversion factor and turn it upside down, or leave it right side up if you need to. Is good? Okay. Oh, I've done something wrong. What have I done wrong? See if you can find it. Yeah, my unit is wrong, yes? I canceled my grams, and what did I find? moles. So that should be moles there. What if I asked you how many particles that was? Do you know a conversion between moles to particles? What conversion factor gets you from moles to particles? Avogadro's number, yes. Okay, so we could say, alrighty, I have, and I'm going to use my unrounded number here, all right? I want to know how many Ca3, I keep forgetting the dot 2H2O, still, I keep forgetting it, Ca3 PO4 2 dot 2H2O is equal to 0.0722 moles. I'm going to get lazy here and not write the compound because I can say that there are, what do I want on the bottom of my conversion factor? Moles. And what do I want on the top? The Ca3PO4 2.2H2O particles. Okay. Whew. What number goes with the mole? Sorry, yes. I'm using the unrounded number, yes. So let's go with 19 there. So what number goes with the particles? Avogadro's number, 6.02 times 10 to the 23. And what number goes with the mole? 1. And now we get times 6.02 E23 equals 4.3459 times 10 to the 22. Ca3PO4, I'm so regretting the choice of this compound. H2O. What would we call those? What kind of particle is that? Formula units, yeah. Could you tell me how many phosphate ions this contains? So this sample would be the Ca3 PO4 2.2H2O. And the phosphate ions would be PO4 3 minus. Do you know how to go back and forth between those two different types of particles? That would be our particle ratio, yes. So we could say, okay, I want to know how many PO4 3- ions I have, and I am starting with this number here, 4.3459 times 10 to the 22 Ca3 PO4 2.2 H2O times, what do I want to cancel? Ca3 PO4 2.2 H2O. And what do I want to find? PO4 3- ions. So we have 2 of those in 1 of those, and we get 8.6918 times 10 to the 22 PO4 3- ions. What we have just done, you could in theory do all in one line. Like if I gave you originally that 25 grams, right? If I gave you that original 25 grams, you could convert it step by step by step by step to find the number of phosphate ions in that sample. Now, this might seem overwhelming at this point, which is why I'll let you guys finish writing that down and then we'll go look at the chart, which should help make this easier. So if we go back to, say here, we started with grams of that great big formula, yes? We converted it into moles of that great big formula. This is on page 3. So if you want to flip to page 3 of your book, we then used Avogadro's number to convert to the particles of A, and then we used the particle ratio to convert to the particles of B. So you could actually say, if I gave you grams of Ca3PO4 I'm not going to put the rest of the formula because it's really irritating me at this point in my life. I can't deal with it anymore. I could ask you for how many phosphate ions, because particle B is the phosphate ions, particle A is the calcium phosphate, so you could go from grams to moles using the molar mass. You could go from moles to particles using Avogadro's number, and you can go from particles of A to particles of B using the particle ratio. There are alternatives. You could go from grams of A to moles of A, and then you could go from moles of A to moles of B using the mole ratio, and then you could use Avogadro's number to go to particles of B. Thank you. Now, we're not going to do all of that all at once. What we're going to do is we are going to go to 5.2. You're going to try actually a few of, where did it go? Oh, molar mass practice. So this is just calculating molar mass. Okay, so this is pages 41 to 42. Do enough to feel good. If that's 3 of them, that's 3 of them, okay? So pages 41 to 42. Where am I going to write this? I'm going to get rid of that. Okay, so 41, 42, enough to feel good about finding the molar mass. And then if you feel like you're like, I don't know about this whole molar mass conversion thing, you could, if you want to, on the weekend, if you're like, Ms. Spence, it was a Friday, I don't know what happened, but I don't understand it, you could go watch Tyler, okay? And Tyler will help you out with the mass to moles conversions, okay? So that is optional, pages 43 to 45. Optional, video pages 43 to 45. But if you're feeling good and you're like, I know how to use a molar mass to convert, I'm good with that, thank you very much, you could just go ahead and do pages 45 to 46, numbers 1, 2, 3. No, let's just do the whole thing. One through 4. There we go. And finally, pages 47 and 48, number 135. I've sort of given a minimal amount, like if you want to fill in the gaps here and do 2 and 4, you could do that, you know what I mean? Like if you're feeling like you've got a little time. I will want to have a quiz on all 5.1 and 5.2 next Wednesday. Quiz on 5.1 to 5.2 next Wednesday. So if you think you need to do a little bit more practice than this on the weekend, go for it.